Let's do another example on calculating your equilibrium constant. Okay, so here's my reaction. You have H2CO3, which is called the carbonic acid, and it's placed in pure water, H2O. Notice the double arrow, which represents it is a reversible reaction, giving you two products. HCO3 minus, which is your bicarbonate ion, and lastly, your H3O positive, which is going to be your hydronium ion. Okay, so this time around, you're given the KEQ, which stands for again the equilibrium constant, which is 4.3 times 10 to the negative 7. Okay, notice it's much lower than 1, which tells you at equilibrium you're gonna have more reactants. Okay. Okay. So sometimes some reactions, not all the reactants are going to form products. Okay. So you just want to keep that in mind, especially when you have a reversible reaction. Okay. So if you're given the concentration for each of the products, which is going to be a very low concentration, 0.000119 molar. What is the concentration of the reactant or the what was it the carbonic acid at equilibrium? Okay, so let's go and set this up. How do we solve for the concentration at equilibrium for H2CO3, which is your again carbonic acid? So instead of using KQ, I'm going to say KC. I'm going to be more specific. This is your equilibrium constant. The subscript C represents concentration. Why? Because we noticed the question or the problem, we're looking at the molar or the molarity for each of the substance. Okay, so again, I'm going to set this up. I'm going to show my expression. Just make sure when you set it up, it's always products over reactants. So my products on the right side. So you have concentration. We use brackets to represent the concentration. HCO3 minus. Okay. Make sure you check the balance equation. Since it's 1 molar, you just take it to the power of 1. Okay. Or just leave as it is. Times the concentration of your other product, H3O positive. Okay, over your reactant, which is H2CO3. Okay, so notice I'm leaving out the water. Why? Liquid water. So just make sure when you are setting up your expression, you want to make sure you leave out these two specifically. Okay, so again, and I'll tell you why in a bit. So leave out solids. So this is where you have to check the phase notation. Okay, solids and liquids. Okay, so why do we have to leave out solids and liquids when we're setting up our equilibrium expression or we're trying to solve for it? The reason behind that is since we're dealing with concentration, right? When you think of concentration, you think of how many moles per how much of the solvent you have or how much solute you have in a solvent. Okay, so when you think of solids and liquids, they're just considered pure, right? You can't have something that's concentrated for liquids or solids. So this is where we don't include it into your expression. Same thing when we're trying to find Kp, which is again your equilibrium constant dealing with pressure. Again, solids and liquids we do not want to include. Okay, so again, please check your phase notation. And anything aqueous, since it's aqueous, it's concentrated. Gaseous, yes, it is, because we're dealing with moles in in a certain amount of area or container. Okay, so again, last thing is this. I'm gonna go ahead and plug in my values. So for each of the products, excuse me, yeah, the products, it's gonna be what concentration is gonna be. Again, 0.000119, okay, times concentration is 0.0000119, or everyone, you just square it since they're both the same value, okay, over X. So X is the concentration for that reactant at equilibrium. And since I'm given my KEQ, I'm just going to plug it in. It's going to be a very small value. It's going to be 4.3 times 10 to the negative 7. Okay, so let's make sure we solve for it. I think it's pretty straightforward. You're going to take, what was it, 4 across the multiple. I'll just do the work for you all. 0.3 times 10 to the negative 7. Okay. X times X, set it equal to, again, 0.000119. Again, square that, or you just multiply it to itself again. And you're going to get a very small number. So 1.40 times 10 to the negative 8. Okay, so after that, go ahead and divide each side by 4.3 times 10 to the negative 7. And you're going to get, let's see. Okay, so you're going to get, here is my concentration at equilibrium for that particular reactant. 0.033. Okay, lastly, I know we said before for your equilibrium constant, there's no unit, but since we're solving for the concentration, you got to make sure you include the unit. So it has to be capital M, which is molar. Okay, so what's my concentration at equilibrium for H2CO3, which is your, again, carbonic acid? It's going to be 0.033 molar. Okay,